All right, it's time to get ready for our Unit 2 test. So let's go through this review. Make sure if you have any specific questions, go to those questions that you are struggling with. But the first one is y equals the absolute value of x. Again, if you don't remember how to graph it, you can go into your calculator, y equals, press math, and go to the right to that abs. Whoops, I wasn't on the right thing. All right, let's try it again. There we go. And then we can put in the x. And there's what the graph should look like. It makes that V. You can go to the table to get some coordinates if you need some. But we'll go ahead and graph it without using the calculator as well. And so the absolute value is going to start at 0, 0. There's no transformations on this one. The slope, that number in front is 1, so we're going to go up 1, over 1, and keep going both left and right. And so there's the absolute value of x. My domain is all real numbers throughout every absolute value function that we're doing. My range, the lowest value is 0, and it goes all the way up to infinity. This one has a lowest point, so a minimum, and it feeds off that range of 0. Feeds off that y value. My symmetry feeds off the x value. It's where the v is cut in half. And so my symmetry is x equals 0. And then if I were to cover up this right side of the graph and read it left to right, it's falling on this side, so it's decreasing on this side, and then increasing on this side. And so it's going to be decreasing from negative infinity to that turning point of 0, and it's going to pick back up from 0 and increase all the way to infinity. That's a terrible infinity. All right, there we go. My x-intercepts, it crosses the x-axis at 0, crosses the y-axis at 0, and then the vertex, the turning point, is at 0, 0. And it says, what is this function called? This is our parent function. There's a parent function for the absolute value. All right, number 2. We'll start off by listing our transformations so we know where our starting point is. And so on this one, our transformations, we're going to have a reflection over the x-axis. And then we've got a vertical compression. I'll just put V compression by 1/2. We're going to the right 2 and up 3. So right 2, up 3, that's my vertex, 2, 3. So 1, 2, 1, 2, 3. My slope on this one is a negative 1/2, so we're going down 1 over 2, down 1 over 2. Do the same thing to the right side as well, down 1 over 2, both directions. And then we can draw that graph. And then once again, my domain is throughout this entire unit, always all real numbers. My range, this one goes all the way down to negative infinity, and the highest point is 3. My maximum, this one has a highest point, so a maximum of 3. My symmetry cuts right there through where x is equal to 2. It feeds off of here, x equals 2. And now on this one, as we read left to right, it's rising on this side, so increasing over here and falling over here, so decreasing over here. So we're going to be increasing from negative infinity to that symmetry point of 2. And it's going to pick back up at 2 and decrease all the way to infinity. This one, my transformations, we've got a vertical stretch by 3. And then down 4. So 1, 2, 3, 4. And then my slope is at 3. So we're going up 3 over 1. Same thing on the other side. Again, my domain is all real numbers. My range has a low point of -4 and goes all the way up to infinity. This is a lowest point, so a minimum of -4. This one cuts the v where x equals 0. And again, we're falling over here, so decreasing and increasing over here. So we'll be decreasing from -infinity to that cut point of 0, and then pick back up 0 to infinity. All right, flipping over on this one. So on this one, we're going to go left 4 and up 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. And we got a slope of -1. So down 1 over 1, down 1 over 1, down 1 over 1. Same thing on the other side, and we can draw that V. Again, my domain is going to be all real numbers. My range has a low -infinity, and it goes all the way up to 5 right there. This is a highest point, so a maximum of 5. The symmetry is where x equals -4. And then on this one, we're going to be increasing over here and decreasing over here. So increasing from -infinity to that turning point of -4, and then -4 to infinity. I write the equation for each of the following. And so start with f of x. We're going to have f of x. We're going to stretch it by a factor of 2. Shift it 4 units to the right. And that's it. Number 6. Start with f of x again. Absolute value that has a domain of all real numbers, that's everything. A range of -3 to infinity. So a hint, if you won't need to, make a sketch. So if you want to make a sketch, the lowest point, so this is a range, this is my lowest to my highest. So my lowest point is -3, and it goes all the way up to infinity. And technically this v could be over here, could be over here, but here's the important thing. Since it's going in the upwards direction, I need a positive number in the front. You can put whatever number you want in front. I'll just keep it a 1. Inside, you could put x plus, x minus. It doesn't really matter what you put inside the absolute value, but I'm just going to keep it in x. But the important part is we're shifting down 3. So these two things are what's important, that it's a positive in front, -3 in the back. Outside of that, you can choose whatever numbers you want. Number 7, again, we're going to have f of x. We've got a compression by 1/3. Reflect across the x-axis, we'll make it a -1/3. Shift it 4 units to the right, so x minus 4, and 5 units up, plus 5. 8 and 9, we're going to be listing all the different transformations. And so 0.75 is in between 0 and 1, so that's a vertical compression. By 0.75, we're going to the right 7 and up 4. On this one, we have a reflection over the x-axis. That's what the negative does. Break apart the negative and the 3. So the negative reflects, and then the 3 is going to be a vertical stretch because 3 is greater than 1. Then we're going to the left 1 and down 9. And there's my transformations. All right, so now we're going to the solving absolute value equations and inequalities. So just as a reminder, our first step that we're going to be doing is isolate the absolute value. After that, we're going to do the split. So set it equal to the positive and the negative, and then we'll solve for x. So those are our steps we're going to be doing. And so on number 10, isolate the absolute value is already done, so it's time to split it. So we'll set that inside x minus 4 equal to the positive 12, x minus 4 equals negative 12. And then it's solving for x. And so we'll add 4 on both sides to get x equals 16. And then we'll do the same thing on this side. We'll add 4 to get x equals negative 8. On number 11, we've got some decimals, so it'd be helpful to have a calculator. But our first step is to isolate the absolute value. So we'll subtract 4.4. So I get negative 0.3. Absolute value of x plus 2.5 is equal to 12. And then we're going to divide by negative 0.3. And so we get the absolute value of x plus 2.5 is equal to 12 divided by negative 0.3 is equal to negative 40. And so on this one I have the absolute value by itself, but on the other side I've got a negative number. Anytime you have the absolute value by itself and a negative on the other side, we're done. Don't do any more work. If you were to split it, you would get some answers that wouldn't actually check. And so on this one, absolute value by definition is always a positive number, and a positive cannot equal negative 40. So on this one, the answer is no solution. So you can either do the 0 with a slash through it or write out no solution. Both of those would work. Number 12, again, we'll isolate the absolute value. So we'll subtract 12.5 on both sides. So we get 4, absolute value of x minus 2.5 is equal to 0. We'll divide by 4, which doesn't change anything. So we have x minus 2.5 is equal to 0. And now we've isolated the absolute value. It's time to split it, but 0 can't be a positive or negative. It's just a 0. And so we're just going to set x minus 2.5 is equal to 0, and we'll add the 2.5 over. And this one's only going to have one answer of 2.5. Number 13, same rules even though it's inequality. And so we'll isolate the absolute value, already done. Now it's time to split it. So we'll do 6x minus 3 is greater than 16, just as it's written. And then on the other side, we're going to flip the inequality and make it negative. So 6x minus 3 is less than negative 16, and then we'll solve both of these. So we'll add 3 on both sides to get 6x is greater than 19. We'll divide by 6 to get x is greater than 19 over 6. That won't simplify. We could change it to a decimal, or you can leave it as a fraction, either one. But then on the other side, we'll do the same process. We'll add 3 to get 6x is less than negative 13. We'll divide by 6 to get x is less than negative 13 over 6. And again, that won't simplify. So we'll put negative 13 over 6 over here. We'll put 19 over 6 over here. Neither of them are equal, so they'll both be open circles. We're less than this one, so shading over here. Or greater than this one, shading over here. On number 14, we'll do the same process, get the absolute value by itself, so we'll add 9 to the other side. And then we'll divide by 3 to get the absolute value all by itself. And now it's time to split. Since this one is less than, you can do it one of two ways. You can either do the 2x minus 6 is less than 6 and also greater than negative 6. Just put it all in one line. Or you can split it into two. Have 2x minus 6 is less than 6, and 2x minus 6 is greater than negative 6. Flip the inequality and change it to a negative. Both of these will get the same answers. I'm going to go ahead and do this one that's on the single line. So I'm going to add 6 to all sides. So I get 0 less than 2x, which is less than 12. We'll divide everything by 2 to get 0 is less than x, which is less than 6. So I'm going to put 0, put 6. Again, both of them are open circles. And on this one, we're shading in between. Then last one, absolute value is already isolated. Time to split it. X minus 2 is greater than 3. X minus 2, we're going to flip the inequality, make it negative. So we'll add 2 to both sides to get x is greater than 5. Add 2 to both sides to get x is less than negative 1. So we're going to have negative 1 over here, 5 over here. Again, they're both going to be open circles. We're less than the negative 1, and we're greater than the 5. All right, moving on to the last page. So again, we're going to isolate the absolute value. So we're going to subtract 12 on both sides. So we get 3, absolute value 2x minus 4 is less than or equal to negative 6. We'll divide by 3. Get 2x minus 4 is less than or equal to negative 2. Again, just like on the front, when you have an absolute value by itself on one side, a negative on the other side, it's time to stop and make the call. So on this one, again, absolute value is always going to be a positive. On this side, we've got less than or equal to the negative 2. And so can a positive number be less than or equal to negative 2? The answer is no. No solution. Number 17, we'll divide by negative 4 to get the absolute value by itself. And so we have absolute value of x plus 2. Since we divided by a negative, we're going to flip the inequality. It becomes greater than or equal to negative 4. Just like on this one, we have the absolute value by itself. We have a negative over here. It's time to stop. We're not going to do any more. We have a positive is greater than or equal to negative 4. And so can a positive number be greater than negative 4? The answer, yes, all the time. So all real numbers. Number 18, we'll start off by subtracting 5. We want to get the absolute value all by itself. We'll divide by 5. 2x minus 4 is greater than or equal to 2. And now it's time to split. And so 2x minus 4 is greater than or equal to 2. And 2x minus 4 is less than or equal to negative 2. And so now we'll add 4. And I'll go ahead and do it on both equations, and I'm running out of space, but we get 2x is greater than or equal to 6, and we get 2x is less than or equal to 2, and then we'll divide by 2. I'll write my answer up here. X is greater than or equal to 3, or x is less than or equal to 1. Again, this one's now equal, so we'll get the absolute value by itself. So 2/5, 5x plus 7 is equal to 56. And then we're going to multiply by the reciprocal. And so we get 5x plus 7 is equal to, let's see, 56 divided by 2 would be 28 times 5, I believe would be 140. I'm going to check my math in the calculator just to make sure I did that one correct. But we have 56 times 5 divided by 2, 140. All right, got it correct. And so now we have the absolute value by itself. It's time to split it. And so 5x plus 7 is equal to 140. And 5x plus 7 is equal to negative 140. We'll subtract 7. So 5x is equal to 133, and also 5x is equal to negative 147. And then I'll go ahead and put these in the calculator as well, but we have 133 divided by 5 to get 26.6, and we have negative 147 divided by 5, which is negative 29.4. And so then maybe you get these decimals on a test like, ooh, I don't know if I did this one right. You can always check your answers by just plugging them in. One thing I showed you all in class is if I can plug it 26.6 stored into my x, and now I can put this equation exactly as it is. And so I can put the 2/5 absolute value, 5x plus 7, subtract 4 on the outside, 52, that checks. Then I can do my other one too. I can put a negative 29.4 stored into the x. And rather than typing everything in, I can just copy and paste it down. Again, it equals 52. That one checks as well. So both answers are correct. I checked them in the calculator as well. All right, my last one. It says for the equation, absolute value x plus 7 minus 1 equals 9 are the solutions negative 2 and 2. Please communicate in complete sentences why these are solutions or why these are not solutions. And so let's go ahead and solve this one. So we'll add 1 over, so we get 2x plus 7. It's equal to 10. We'll divide by 2 to get absolute x plus 7 is equal to 5. And now we'll split and get x plus 7 is equal to 5. X plus 7 is equal to negative 5. We'll subtract 7 over to get x equals negative 2. We'll subtract 7 over to get x equals negative 12. So -2 was one of the correct answers, but 2 was not a correct answer. And so I'm not sure exactly how they got these two answers. No work to check how they got those answers. So let's not worry about this last sentence. And those are my correct answers. So are those the solutions? No. These are the correct solutions, -2 and -12. All right, and that ends our review. And so make sure if you have any questions, let me know. But good luck on this test. Whoops, I went down below the screen, but there we go.